Hello guys, welcome to cLearning with new video. In this video we will learn about IPsec tunnel VPN in IKE mode. In our last video we learned about IPsec tunnel in manual mode. I use the same topology in my previous video where I create the IPsec tunnel in manual mode, where we do the configuration of IPsec and we manually define the SPI keys, SPI share keys and SPI string keys in both side of tunnel. But in this video we will learn about IPsec IKE mode, automatic key exchange mode, where uh, we define both in both side of tunnel IKE pair, and we just define the pre-shared key in either side of tunnel, and it automatically do the pick the configuration and make the tunnel. So let's go toward the configuration. So I just do the configuration, the basic configuration of a layer 3, where I give the IP addresses to all the routers and the PCs as I define in uh, above labels. This configuration I have done, and the 30.1 IP address on this interface of router and the 30.2 on this interface of router. So I just given the all IP addresses, and also I use the OSPF protocol to do the configuration. So layer 3 is complete. If you want to do the configuration or want to see the configuration of layer 3, you can watch my previous video, the IPsec tunnel in manual mode. Now here we just start our configuration from configuration of IPsec tunnel. So just verify just tunnel is layer 3 is complete or not. So 10.2 is the IP address of this, and 70.2 is the IP address of this PC. So just ping the 70.2, ping 192.168.70.2. Let's wait and see. Yes, it's reachable. So it means that from here to here the connectivity is full, layer 3 is complete, OSPF routing protocol is running. So just let's display current configuration. So you can see here on G001 this IP address I have given, on 00 this IP address, this is the 00, and 002 this IP address, and also I have used the OSPF routing protocol area 0, and in area I define these three network. On these three network I have defined. So layer 3 is complete, full connectivity. Let's start the configuration of IPsec tunnel in IKE mode. So let's here, if we want to do the configuration, we want to make the tunnel. So I have given this label. So our tunnel will be from here to here and here. So two ends of the tunnel are one router, this router, and other one is this router. So we do the configuration on this router as well as on this router. So end of the tunnel. So we do this configuration. I have write the configuration step here. IPsec tunnel in manual. First of all, we create the ACL security. We define the extended ACL on or advanced ACL on both sides, and then we create IPsec proposal, then we create the IKE proposal, and then we create IKE pair, and then IPsec policy, and assign that both policy on particular interface, like on this interface and on this interface where we want to create the tunnel. So let's start the configuration of IPsec. Okay, quit system view. First of all, we create the IPsec ACL. So ACL 3001, sorry, ACL 3001, and rule 5, permit IP source 192. what is our source? So this is our one network, one branch, and this is our another branch. We create a tunnel from one branch to another branch because we want to transmit our data over the internet, but is in encrypted form. So the purpose of IPsec tunnel is to send data in encrypted form over a tunnel over the internet. So it's a VPN. So what VPN do, it create a tunnel over the internet and transfer our data over this tunnel, so no one can access our data, and data would be in encrypted forms. So we also use some encryption algorithm on this tunnel, so our data is transmitted into convert into that encrypted forms and then transfer to. So first of all, so we create ACL from this branch to this branch. So our source is this branch and destination is this branch, so both we want to uh, convert, transmit and receive data from these two branches. So this is our source, this is our destination. So source is 192.168.10.0 sorry 0.0.0.255, the whole network, and the destination is 192.168.70.0.0.0.2 sorry 0.0.255. So this is our 255. So so you can see here source is this 192, sorry 168 70.0. Okay, so here is the mistake, it's 68 not 69. So be sure about these little mistakes. So we have to given rule 5 permit so we have to undo the rule, so it's mistake, undo rule 5. Okay, so rule 5, we again create this rule 5 permit IP source 192.168.10.0.0.0.255, and the destination is 192.168.70.0.0.0.255. So now we create so let's create this ACL on other side as well, on this side as well. So system view ACL 3001 rule 5 permit IP source 192. Here is the source is this one, because we are on this side, so here source is this one and destination is this one. So we define source 192.168.70.0.0.0.255, and the destination is 192.168.10.0.0.0.255. So we create ACL. Now we go on router 1, we here create the IPsec. So you can see here we have to create ACL on both sides. Now we create the IPsec proposal on both sides. So let's create the IPsec proposal. So IPsec proposal, and now the name of proposal, you can see that P1, C1 or any. So I giving the P1 is name, you can use any name P1. So now we create what we define in this proposal. So we have to define the authentication and encryption algorithm. So encryption mode is sorry ESP. We have to give the command ESP encryption algorithm. So if you custom mask, so you can use any encryption. So I am using 3dash. So authentication algorithm ESP authentication algorithm would be, so I'm using SHA-1. You can use any, but you have to use, if you are using SHA-1 in this side, so you have to use the SHA-1 on other side of tunnel as well. So both protocol and encryption algorithm should be, configuration should be same. SHA-1. So we create IPsec proposal. Now we go back and we go on this side of tunnel on router 5. So we do the same configuration of, we create IPsec proposal You can name the proposal any name is not mandatory, so I am giving P1. So ESP encryption algorithm would be our 3 days. ESP authentication algorithm would be our SHA-1 and quit. Now we go on router 1, and now we have what we have to create. We have to create IKE proposal. So in IKE proposal we do somewhat the same configuration. We have to define the encryption and authentication algorithm. So IPsec IKE, sorry, IKE proposal. So you can name the IKE proposal. So I am giving I1. So I1, sorry, integer. So I'm giving the 5. So now we define the encryption algorithm. If you question mark, so you have to select this encryption algorithm. So I am using 3-dash CBC and authentication algorithm. If you question mark, so you can see here the AES SHA-1 MD5. So I can use, you can use anyone. So I am using here SHA-1. And now you have to define a DH group. It's not mandatory, but if you define, so it's very good. DH is Diffie-Hellman group. So DH, so group 1, group 5, so it's a Diffie-Hellman, so it encrypt your data up to that bits. So group 14. So I'm using group 14. So yes, so just go back. So this is the proposal. So now you have to define IKE proposal here as well. IKE proposal 5 encryption. If you question mark, so 3-dash and our authentication would be SHA-1. DH group would be group 14. So if you question mark, so you can see here here the wait, DH is a specific DH group. If you write DH, so if question mark, so you had 72 bits Diffie-Hellman group. So it just encrypt our data up to that extent. So now we create IKE peer. So on this router, now we create IKE peer. In IKE peer, so name of IKE peer, so I am giving the I1. So here the name of peer. So now you can see here error, peer is new, so initiate the mode to finish the clear it. IKE peer name, okay, IKE peer 5. If you question mark, so you can see ABC, okay. If you question mark, so we have to give the version as well. So IKE peer, I'm just using the name I1 and then version 2. So now in IKE peer, now we are in IKE peer, so we have to define the IKE proposal that we define in previously. What IKE proposal? In IKE peer you have to define the IKE proposal. So what was the proposal? 5. Proposal 5. Now we have to define the pre-shared key in cipher. So any key you can write here. So I am giving Huawei 123. So here, so and now you have to define the remote address. So what is the remote address? So you are here, so this is your local address. So this is the start of tunnel, so this is your local address, this interface, and this is your end of tunnel. So this is your destination remote address. So we give this remote address on that. So remote address is 192.168 60 192.168 60.2 2 on this side. So this is 2. So we have to define the IP remote address 192.168.60.2 60.2, and yes, so this is here we are done with IKE peer. So we quit back, and here on this interface as well we do the same IKE pair I1 version 2. Here we have to define a IKE proposal 5, and then pre-shared key in cipher Huawei 123. So key should be same, so remember this key should be same on both sides, so care about it. So remote address is 192.168. So here the remote address from this router, the remote address, what is remote address? This is the remote address. So here the address, physical address on this interface is 20.1, 192.168.20.1 on this side, 20.2 on this side. So 20.1, 192.20.1. So this is, we are back now. We create IPsec policy. So you can see here, after IKE proposal we create IKE peer on both sides. Now we create IPsec policy on both sides. So here we create IPsec policy for IPsec policy. So name of policy P1, and then if you question mark, so we are not using the shared policy, we use the sequence number 10, and here we have to use the ICMP. So we are using indicate that IKE to establish the IPsec security association. So our in manual mode we define security association manually. So here we use IKE, it automatically define the security association SPI and string keys for IPsec. So we are using ISAMP. If you question mark, so bus okay. So just we write, and now we define the IKE. Here we have to define the IKE pair. So what was the IKE pair name? I1, and here we define the IPsec proposal. Sorry, proposal. What was the proposal name we defined? We defined the proposal name was P1. So you can see here in previously we defined the proposal name P1. So proposal name is P1. We also define the IKE policy name as P1. So remember one thing, this proposal name is different and the policy name is different. So you can use two different name, proposal name different and this policy name different. So I just mistakenly use the same name, so it's not to worry about, just clear your concept. So we define the proposal name. Now we use the security was ACL 3001 that we used previously, and just quit. So we define these three things: IKE pair, I1, IKE proposal, and then security. Now we go here. So here we also define IPsec policy P1 10 and then ICP. And now here we define the security was ACL 3001 and the proposal was P1, and then IKE pair was I1, and just quit. Now our last step is to just apply this all the configuration IPsec policy in a particular interface. So we are using this interface for IPsec tunnel. So now we go in this interface gigabit tunnel 0/0/1. So you can see here this is the 001. So when here we define the IPsec. So IPsec policy, so just give the name of policy P1. So we define this policy on that particular interface. Now we go on this interface gigabit 0/0/1 IPsec policy P1. So just define this policy P1 on this interface, so you can display this policy. So either we do the configuration or not. So display IPsec policy statistics, wait, IPsec statistics ESP statistic, if you question IPsec policy policy. You can see here where policy name is P1. In this policy we use the ACL 3000, and peer name was IKE peer I1, and we use the proposal name P1, and here we use the uh, local association is used by this IKE peer, and we don't need to define this IPsec ISA security association, and you can see SA trigger is automatically, and our route injected none. So we use this configuration. So let's see either this reachable or not. So we are pinging this destination, so our destination is reachable. So let's see our destination reachable through our tunnel or not. So we use a command trace rt 192.168.70.2. so just trace route. So you can see here the trace route. Here in trace route you can see our first destination. We are ping, we'll take the trace route from this source to this destination, on this destination. So you can see here all the tunnel is skipped and bypassed. So what VPN do, VPN bypass all the network and just reach the destination. So our end of tunnel is 60.2, so it bypass all the tunnel. So it doesn't take the trace route or on this hop, on this hop, on this hop, on this hop. It just bypass all the network on tunnel and just reach the end of tunnel. So 60.2 is the end of tunnel and 70.2 is our destination. So that's how VPN hide all the destinations, and it does not allow the someone to eavesdrop our data. So it bypass all the network, it hide all the networks, so no one can knows that our data is passing through which destination and which hops on which network on internet. So it just bypass. So we verify that our tunnel is working. So this is the end of tunnel and this is our destination. It's bypassing all the networks, so it means that our tunnel is working. So let's see either this encryption, the data passing through this tunnel is either in the encrypted form or not, because we are using IPsec tunnel and we are using encryption algorithm in it. So our tunnel is fully built. So let's see our data passing through this tunnel is either is encrypted or not. So just take a ping and minus t. So this is, it means that we are using trace or continue ping. So if we use this ping, so it only take the 5 traces. So if we write minus t, so it continue ping, so it will not stop after 5 pings. So you can see here it will not stop after 5. So you can see 5 ping has been complete, so it continuously take ping until we manually stop it, cut it. So let's see. So data is passing through this tunnel, so we take this interface Wireshark. We open this interface or Wireshark. So let's see our data is passing through that tunnel. This G001 is in encrypted form or not. So you can see here our data is passing through 20.1. What is 20.1? So this is the 20.1 is the start of tunnel, and 2060.2 is the end of tunnel. So this is our source and this is our destination for tunnel. So let's see. So you can see here 60.2 is the destination and 60.2 is our source. So here we are using the protocol ESP. ESP is encryption protocol, so encapsulation protocol. So it means that we are using our protocol is encrypted protocol in this tunnel, and data is passing through this tunnel is encrypted form. So if you want to know about more about this encryption and details, so you can watch my IPsec manual mode here, on this video. I define this Wireshark in more detail. So thank you very much. If you have any questions, so you can ask in comment. So thank you very much.